All right, everyone. We're going to get started. This is the first tutorial session of PyData Boston. So I'm just going to introduce Gilberto Hernandez. He's lead developer advocate at Snowflake. And so I'll let him take it away. Thanks so much.
Yeah. Thank you. Appreciate it. All right. Good morning, everyone. Thank you so much for coming to my session today. So for folks who are just joining us, this is a tutorial from notebook to pipeline, hands-on data engineering with, from notebook to pipeline, hands-on data engineering with Python. So we have quite a bit to cover today. This is a tutorial. There's always a bunch to do, a bunch to set up, and just a bunch generally. So before I get into the cool technical details, I just want to give you a little bit of background on myself. So as Ben mentioned, my name is Gilberto Hernandez. I'm a developer educator. There are a couple of things you should know about me before we get started. So I'm not going to do like a full resume rundown and bore you with that. But the first thing you should know is that I got a haircut, so I look a little bit different from my profile picture here. The second thing is, as I mentioned, I'm primarily an educator. So I've been educating developers for over a decade at this point, all sorts of concepts, all sorts of areas. Just to give you a couple of places that I've been at in the past. So if you've ever used Codecademy to learn how to code, there's a good chance you took a course that I wrote. I was one of two course creators there back in 2015. If you've ever used MongoDB, specifically MongoDB Atlas, I was a product manager there, focusing on technical documentation and the technical documentation platform. So if you ever try to connect your application to a MongoDB Atlas cluster, you probably read some docs that I wrote as well. A couple of other cool places that I've been at in the ML and API space as well. Today I'm at Snowflake, lead developer advocate, as Ben mentioned. I focus a lot on data engineering, application development, and I'm based out of Austin, Texas. This is my first PyData ever, and this is my first time in Boston, so I'm super excited to be here. All right. So here's what I'm planning on covering today. So the way that we're going to structure this tutorial today is it'll be kind of part overview. That'll be the first part. I'm going to try to keep that part really short. After that, the rest will be hands-on. So it'll be a lot of working in a notebook. Sorry, come on in. It's OK. Now I'll try to optimize for making sure that we are actually in a notebook and lab environment for as much as possible. All right, so here's what I'm planning on covering today. So again, just to start with some context and motivate our tutorial today. So we'll talk about what exactly is data engineering. We'll talk about a framework for understanding data pipelines as part of data engineering. What data engineering looks like with modern cloud data platforms today. And then after that, diving into our hands-on tutorial, we're actually going to build a data pipeline using Python in a Jupyter notebook. All right, so let's go ahead and get started. So just to start, what exactly is data engineering? It's good to have this context before we dive into more of the concepts. So a few years back, Snowflake published a book called Cloud Data Engineering for Dummies. And it had a pretty good definition in there that I think captures the essence of what data engineering is. Obviously, it's a pretty broad discipline. So definitions vary from source to source. But there are commonalities that you'll see once you start diving into this field. So here's the definition. The overall data engineering is the overall effort required to create data pipelines that automate the transfer of data from place to place and transform that data into a specific format for a certain type of analysis. It's not something that you do once. It's an ongoing practice that involves collecting, transforming, and delivering data. So again, depending on who you ask, you may this is maybe up for debate, but in general, if you start diving into understanding what this discipline really entails, you'll find these commonalities. And so one thing that I like to do is, as I read this definition, I find some words that stick out. So a few things: data pipelines, automate, transfer of data, transform that data, and then there's this notion of collecting and ongoing and delivering data. And so the way that I like to take these words that stick out and that are pretty common across just different sources for this definition is to try to build a framework around it to try to understand and contextualize data pipelines. So the way I like to think about it is using the ITD framework for data pipelines, where the I stands for ingestion, T for transformation, and D for delivery. Where ingestion simply means loading your raw, unchanged data into a data platform. Transformation means using SQL or Python or any other languages or primitives to transform that raw data. And then finally, delivering a final data product to your data consumers, whether that's a data set, and then what you're seeing today, just given all of the frenzy around generative AI, is semantic models as an example. This is around the time where I start getting questions around, why aren't you talking about ETL? Why aren't you talking about ELT? Aren't those the same things? And yes, you have a point. My aim is to try to give you a framework that you can use to build a mental model that'll help you contextualize any pipeline. And that's my claim to you, any data pipeline. That if you think about it in terms of ITD, you'll be able to understand the core components of that pipeline. And as you level up and just kind of get more experience in data engineering and building data pipelines, I assure you there are going to be no shortage of more acronyms that you have to learn. So ITD, and then later we can talk about ETL, ELT, and all the other fun acronyms that are present in data engineering. All right, so what does this look like in modern cloud data platforms? So what I'm going to show you here, and I'm going to take this step by step and go through ingestion, transformation, and delivery. Not really focus on how a specific platform offers certain features to do things, but I want you to extract the patterns that you'll see across these different parts of the framework. So I'm going to speak to the data platform that I'm obviously very familiar with. So that's Snowflake. But the core things that you're going to realize or at least identify that are common across modern cloud data platforms in this space of ingestion is that they're typically solving for a couple of really important things. The first is types of data. So what kind of data can that platform ingest, whether it's data in CSV files living in cloud object storage, or if you're trying to optimize for data that is being originated really quickly and you're trying to capture it. And then the second is, of course, latency. So how fast do you want to get that data into your data platform? That will depend on your use case. So you may have, for example, scheduled ingestion into your data platform, and maybe that happens every 12 hours, every 24 hours. Could be very different just depending on your use case. Or again, you're looking for something more real-time or near real-time, where you're trying to ingest data as soon as it's originated. So that could be, as an example, capturing data from an IoT device. It's like on a manufacturing floor. In the middle, we have transformation as part of ITD. Transformation is a pretty broad area of this framework. So you'll notice that most modern cloud data platforms are going to give you different options and tools and technologies to be able to transform your data based on your desired preference. So some of these will be in the form of languages, right? Hey, I prefer SQL. I prefer Python. Some of these are going to be in the form of specific, what we call primitives, for being able to actually transform that data. That could be stored procedures. That could be user-defined functions. That could be ability to support data frame operations directly in your cloud data platform. That could be a delta-driven object, meaning that this is a table that will process only incremental changes to new data that's loaded into your data platform. We'll dive into more details in a bit. We really don't need to cover every single aspect here, but the important thing is here, this will vary depending on the platform that you're using, and I'm just giving you a sample of what this looks like in Snowflake. And then for delivery, you'll notice that this is present in both ingestion and delivery, and that's because many times as part of ITD, as part of building a pipeline, maybe you are trying to get data out of your system as well to feed it into another system or deliver it to some other data consumer. But as I mentioned earlier, when I talk about delivery, I'm talking about delivering a data product. And that has been a term that I've seen kind of come to popularity over the last 5-10 years, right? What does that mean? It's going to mean different things depending on the use case. For example, when I talk about getting data out of your data platform, you could be delivering a final polished data set, or it could be a final polished data set inside of that platform for more users on your team. But then I mentioned earlier with the rise of AI, you're seeing things like, hey, I really need a semantic model that's built on top of this data that I can use as I build out an agentic workflow, either in that same platform or outside of this platform. Sorry, I'm not sure why this keeps doing this. Okay. Another cool thing you'll see is that a lot of modern data platforms will allow you to do this data sharing, meaning you can grab data sets that have already been curated, that have been processed from trusted third parties, and then you can also list your own if you wanted to on a marketplace, as an example. You can also build really cool Python-based Streamlit apps as well. So that's what this looks like in Snowflake. But again, the important thing is to think about the patterns and the commonalities. So first, ITD as a framework for contextualizing a data pipelines, and then understanding how, as part of that framework, the patterns you'll see that support those things in any modern cloud data platform. There's also this aspect of automation and kind of DevOps. So I don't really consider this as part of the ITD framework, but what's really neat is you'll notice that there are options for developers, for data engineers to build out data pipelines, whether you're working in a workspace or a notebook as we'll use today, or maybe you want to work using an extension as part of VS Code, or working directly, integrating directly with Git so that you can source control your pipelines. All right, so for today's tutorial, obviously we can't cover everything that I showed in the previous slide, but these are the core things that we'll use to actually build out our pipeline. So for ingestion, we're going to schedule a copy into command that's going to bring in about 1 billion rows of data from Cloud Object Storage into Snowflake. For transformation, this is PyData, so we're going to work with Python. We're going to use a little bit of SQL, and I'll give you some more details on why when we actually get into the details. We're going to use dynamic tables, and I'm going to dive into a lot more detail as well as we get into the notebook. But dynamic tables will be able to do our transformations for us in an automated fashion. And then it'll also only process incrementally, just basically only data that's changed at the source. We're going to use a distributed compute engine, so I don't want to run into any memory issues based on the limits of my computer and what it can handle. So I'm just going to use something that is in the cloud. And then for delivery, I think it's really cool that you can build a pipeline and focus on ingestion transformation. But one thing that I've seen with data engineers is many times they may not be present in the usage of their data product because they have another pipeline to build. But I think it'd be really neat to show you exactly how you can use that data product after you build out a pipeline. So what we'll do is we'll build a semantic model that we can use in an agentic workflow. And of course, we're going to be using notebooks for today's tutorial. If you haven't already connected to Wi-Fi, it'd be a good time to do that, just because there are going to be a couple things we'll need to do. Nothing too bandwidth intensive, but it's a good idea just to get connected if you are following along today. All right, so here's my recap. So just key points to keep in mind about data engineering and data pipelines. Data engineers are building data pipelines that can ingest data, transform it, and deliver it to a data product to a consumer or system. ITD is a great way of contextualizing the components of a pipeline. I for ingestion, T for transformation, and D for delivery. Modern data platforms should offer you a versatility in how you ingest data, support various languages and tools for transforming data, and also give you different options for delivering data products. They should also offer flexibility in how you develop and deploy your pipelines, whether that's through code editor extensions, notebooks, CLIs, or other options. All right, so like I said, I want to keep that part really short so that you have enough context as we dive into the tutorial. I will keep coming back to a couple of these slides just to show you and illustrate where these points are being used throughout our tutorial. But that's kind of the short part, the short overview that I'll cover before we get into our tutorial. So with that, we're ready to go ahead and get started. Before we start setting anything up, and again, if you're not already connected to Wi-Fi, please do so. I do want to give you a scenario for the pipeline we're going to build today. Let's imagine you are a data engineer for a fictional company that's called Tasty Bites. They run hundreds of food trucks around the world. You get pinged from data analysts all the time. Hey, what are the top 10 products by revenue? All right. Rather than give those data analysts one-off answers for their questions, we want to build something that's going to allow them to self-serve And so yes, I could provide them with just a table, but we want to go a step further and maybe give them an interface where they can just ask questions about the data in natural language. And so I was talking earlier about building a semantic model that we can use in agentic workflows. We'll get to that part at the very end. So here's what that pipeline is going to look like from like a reference architecture perspective. So I mentioned I have a bunch of CSV files living in cloud object storage. I think I have roughly 400 files containing about 1 billion rows spread across all those files. What I'd like to do is ingest that data into my data platform. So we're going to run a copy command to take all that data and land it as tables. And so we'll have a raw zone with 3 tables: order header, order detail, and menu. Right? And we're analyzing a bunch of sales data around food truck sales. So that, the table names ought to reflect a little bit, what the data actually is. And then we're going to build out our kind of 3-tier pipeline. All right, so we'll have tables that basically have upstream dependencies. So as an example, we'll have 3 tiers. The first tier will be, we will enrich our orders and order items table, right? And we'll build those from the raw tables here. But I mentioned we're going to use something known as a dynamic table, which means that I can chain together these tables in these different tiers. And then I'll have, as an example, order fact building from these tables. And in tier 3, I'll have these 2 tables, which are going to contain the exact data that I'm trying to deliver to my data analyst teammates: daily business metrics and product performance metrics, and they're building off of order fact. Now, the reason I have these grouped together and I'm showing these arrows here is because this is an entire, this pipeline is orchestrated in a way where you can see the dependencies. So from, you should think about the raw tables as your source. It's upstream. And then down here being very downstream, right? So, and then it's all relative. So these tables are downstream to order fact is downstream to these tables here, so forth and so on. One thing you'll notice is I call out this notion of a lag. So one thing that I see data engineers typically, their environment typically work with is they're running scripts in an imperative fashion. And what I mean by imperative is that you're running a sequence of scripts in hopefully the right sequence to get you from, let's say, the state A of a table to state F, right? So you'll run script 0 and then script 1 and script 2, and you're transforming that table in a step-by-step fashion. And you're hoping that as you do this, you run them in the right order. If not, you may make a mistake and you have to roll back and you kind of keep going back and forth between these different scripts. What I'm going to do here is I'm going to use a declarative way of actually defining those transformations. Declarative just means I'm going to define the end outcome, so what I want these tables to look like, and then forget about it. Right? I'm not going to manage scripts individually and orchestrate them. And that's because what we'll use with dynamic tables is that with the lag parameter, the orchestration is taken care of for me. So as an example here, what does lag 12 hours means? It means that these tier 1 dynamic tables should update within 12 hours of these raw tables receiving new data, right? So one thing that, obviously we're not going to wait for 12 hours for new data to load, but one thing you would typically see in a pipeline is, let's say that this AWS S3 bucket is receiving new CSV files every 12 hours, every 24 hours, nightly. You would have a task to ingest this data perpetually into these tables, right? We're not going to be using a task. I'm going to be simulating loading into these tables with some other object, which I'll show you in a bit when we get into the notebook. But the key point for that is, as we load more data into the raw tables, you'll see how these pipelines will refresh automatically. Sorry, these tables will refresh automatically as part of my pipeline. And because we won't be waiting 12 hours, and this is configurable, but this is just an example, I'll just manually refresh them. And downstream, you'll notice, it's not hours, it's not minutes. It just means, hey, when your parent tables update, you should check for updates and then refresh if they have updates. Also, don't reprocess 1 billion rows. Just process the 500 or 1,000 rows that came in from orders that happened yesterday, as an example. So once we have these final tables in our tier 3, zone, we'll do a couple of things. We'll build our semantic model using Cortex Analyst, and we're going to bring that into a feature known as Snowflake Intelligence for using an agent to talk, an AI agent to talk to the data that's in these two tables. And you can imagine that your analyst teammate, this is what they're using. You're building out this entire pipeline for them to be able to use that here. And just to give you a screenshot of what this looks like, it's just basically being able to ask questions in natural language about that data. We'll do something more interesting than just top 10 products per revenue, but this gives you a good example. All right, so here's what you're going to need to build along, and I'm going to give you some options based on your level of expertise. So these are just the core requirements, and if you don't have all of these, or you don't know how to set them up, that's fine, because I'm going to give you, again, a couple of different options depending on your level of expertise. So you'll need to be able to run Jupyter notebooks. You'll need at least Python 3.10. You'll need either pip or conda. You'll need a couple of Python packages, so Snowflake and Snowpark Python. I'll dive into more details on what those do later. Obviously, you'll need an internet connection. This is high level. Like, this is just the core. These are the core things that you'll need. But you don't necessarily have to fuss with all this if you don't want to. So I'm going to give you a couple of options. Actually, before we go into options, no matter your level of expertise, these are the two things that you'll need to actually participate. Right, so the Jupyter notebook that contains the code that we'll run and write is at this URL. I try to shorten it as much as possible, but if you type that into a browser tab, this will take you to the GitHub repo that has our notebook in there. I'll open it in just a bit. And then this is a 120-day Snowflake trial account. It's completely free. Get a lot of questions on this. Is it really free? Yes, it's free. There's no credit cards. There's nothing. It's $400 of credits. One really cool thing about this specific URL is that the normal trial account for Snowflake trial accounts, the normal duration period is 30 days. I'm part of developer relations, so I'm part of an education team. We're able to give out 120 days, so it's 4 times the length of the normal trial account duration. So it's good to kind of type that into another browser window and another browser tab and just have those two things open. So the notebook, and this will lead you to the GitHub repo, and then, of course, the trial account. And let me just show you what those look like before I keep going. So I get to just copy and paste this. So this is what it looks like. You don't need to clone anything if you don't want to. You can simply go to Python Data Pipeline.ipynb and download it. You can do that now, or you can do that in a bit, because we're gonna do some more setup later. So don't feel like you have to do this right now, but it is good to at least have this open. So again, this is the URL that will take you to the GitHub repo that contains the notebook we're gonna be using. The second URL, and I try to pre-fill as much as possible for everyone here, is just gonna take you to a form. So your name, email, you'll get a small survey about why you're signing up. You can skip it. This is going to open up your Snowflake account. You'll get an email, and it'll say activate it. Once you click on that, typical flow is create a username and create a password. And that's it. You're in. You don't need to do anything else. Some folks are going to spend time in Snowflake today, again, depending on your expertise level. I'm actually not going to be in Snowflake. I'm going to be working directly from my notebook. This is PyData, after all, so I'm going to be in my Jupyter notebook working with Python. But if you are going to be working inside of Snowflake, I'm still able to guide you. So again, I'm going to give you different options for participating in this tutorial. But you're going to need, everyone's going to need, regardless of whether or not you're going to be in Snowflake or not, you're going to need a trial account so that you can use those compute engines that I mentioned earlier. Yes?
Can you show the link to get there again?
Sure, sorry. There you go, yeah. Yeah, all you basically need to do right now is have these two things open. And sorry, I'm just trying my dongle real quick to see if I can help with the blackout issue of the screen. But if you just navigate, so open up a browser, create 2 tabs. One tab, you can have the repo. You don't need to clone it. You can just download the IPyMB file directly, or if you are comfortable with Git, you can clone it. And then the trial count, everyone's going to need this just for the compute engine. And also, depending on your level of expertise, you may spend some time in there today. All right, so here are the environment options. Again, you get to pick based on how comfortable you are with some of these things. So option A, if you're comfortable with running Jupyter notebooks in your own preferred environment, you're comfortable managing Python versions, so using pip, comfortable using pip, using conda, creating or managing virtual environments, then basically you can take that notebook and use your whatever notebook environment you typically use, whatever environment you typically use to work with your notebooks locally. I would say that this option is for intermediate to advanced folks. Just note that if you go with this option, there are a lot of you here, so I can't necessarily go around and help everyone set up their development environment locally. All right, so if this is going to be a good fit for folks who do this on the daily, as an example. Option B, if you don't want to fuss around with anything from option A, you can simply take the IPyMB file that is in that repo and load it directly into Snowflake. So I built out the notebook to be able to accommodate both options. So it doesn't matter what option you pick. You can follow along with me. This option is really for anybody. You could be beginner, intermediate, advanced. You just don't want to be bothered with any of the stuff that's in option A, because I know it can be painful and just not fun. Again, the notebook will work regardless of which option you pick. I'm going to be picking option A. So it doesn't matter, though, because, again, if you pick option B, I'm still able to guide you through the notebook in Snowflake. And you'll see there are clear notes in the cells that say, hey, run this if you're in Snowflake, run this if you're outside of Snowflake. So again, pick based on your level of expertise. I do want to get a quick poll really quickly just to know how to structure the rest of the tutorial. How many folks are thinking about doing option A? Cool. Yeah, and I'll show you how to set all that up, connect to Snowflake. How many folks are thinking about doing option B? Cool. All right. So good mix. So let's get started. We have about an hour left, and we have a lot to cover. But I'm gonna show you how to. I'm in option A, so I'm gonna be in my notebook. I'm specifically going to be using VS Code, which already supports Jupyter notebooks, and you'll see how I'll connect to my Snowflake account. If you haven't already, so here, I'm in VS Code. If you haven't already locally opened this notebook, if you are in option A, now's a good time to do so. If you're doing option B, if you navigate down to the setup zone, you'll see some instructions for option B, and you should follow these. So you've already created your account. Basically, you just need to go into the notebook session and then import that file. And that file is here. Again, if you don't want to use Git and clone this locally, you can just go to this file here. You can click on download. It's not that big of a file, and then you can just load that directly. Right, and I can walk around here, and if folks have questions, happy to help. Yes? All right, so let me log into my account, and I can repeat these steps as well. Let me just show you what this looks like if you are doing option B. So let's see. All right, so this is my trial account. I have nothing in here. And all I'm going to do is I'll go to projects, notebooks, and these are the same instructions that are in that cell in the notebook. Oh, sorry, notebooks. And then I'm just going to import the file. And again, this is that IPyMB file that's in the repo. And you can leave everything in this modal as is and just hit create. So this is just open up the notebook inside of this environment. And there are only two things you'll need to do to actually do some setup. And you don't have to write any code. You just basically have to install the two packages that we're going to use in the notebook. So in the packages drop down to the top. And again, I can go through all these steps again for folks who haven't yet gotten the email. I'm going to search for Snowflake. I'll click on it. Once I click on it, it's already installing it. And the other one is Snowflake-Snowpark/Python. This is the package that lets me do data frame operations against tables in Snowflake. And then I'll hit save. Make sure you hit save. And then you'll see that your environment will have been updated. So this file will be created. You can check it out. You don't have to do anything, but I just want to, it's a good little indicator to show you these have been saved. And that's it. You're set up and you're ready to go. Yes?
Can you go back to the first part where you're downloading
The notebook?
the notebook?
Sure.
Just real quick.
So just to show folks how I got there. All right, so the notebook is going to be at this URL. This URL will take me to this GitHub repo. And in this repo, 3 files. You want to download IPyNB. If you click on that, there will be a button right here. Download. So that'll download it to your local machine. Just keep in mind where you save it to. Then once you're in Snowflake,
Yep. Got it.
you're good?
Thank you. Yep.
Yeah, in the notebook's UI, and this is, again, these instructions are in the cell in the notebook. You just import that. Have you still not gotten it? The email?
I do. If I
Okay,
found
cool.
it, I have it. I don't know what to do.
Okay, yeah, I can walk you through it. Sure. Option B? Are you doing option B or option A?
I don't know what option B or A is.
Okay, option B is basically you can work inside of Snowflake.
Okay.
Yeah, yeah.
I'd rather not.
Okay, you want to work locally instead? You want to do option A?
Yes.
Okay, sure. Let's see here.
Do you,
Yes. Option A, folks, how, can I just quick poll? How many folks are ready to go with option A? Cool. Option B, folks? Good to go. About 30 more seconds, 1 more minute. Awesome. So if you are in option B, remember that simply importing the file into Snowflake is not the only step. You do have to install the 2 packages. So using the package picker at the top, just make sure you type in Snowflake and then Snowflake, Snowpark, Python. And the instructions to do that. Sorry, I'm not sure why this is happening, but bear with me. The instructions to do that are actually already in the notebook. So if you click on cell 5, which you can quickly jump to by just clicking here on the right, those are the instructions. All right, so let's see if we can build this pipeline in less than an hour. Cool. So I've already covered the scenario and the pipeline, right? So we're going to have a raw zone with a few tables. We're going to create 3 tiers of dynamic tables, right? So first we'll create 2 tables, order headers and order items. I'll zoom in a bit. Then we'll create fact table, which builds on those. Then in tier 3, we'll create our metrics tables, which builds on tier 2. And then again, I mentioned this is an extension. We'll generate a semantic model so that you can do basically AI-assisted queries. This is a setup zone. I think most people have already covered this, regardless of whether or not you're option A or option B. All right, so if you are in the notebook, the first thing that you need to do is to be able to connect to Snowflake. Actually, the first thing we need to do is actually import the right things that we'll use for our lab. So I've already gone ahead and made this cell. I'm just importing what we're going to use to create different objects throughout Snowflake. So the 2 packages that we're going to use, Snowflake and Snowflake Snowpark Python. Snowflake is the the Snowflake package basically gives me API programmatic access to Snowflake. So I have access to databases, compute resources, tables, that kind of thing. And then Snowpark is basically how I can do data frame operations against that data. All right, so you need both. This cell you can just run. All right, so I've loaded those into my environment. For folks who are in option A, this is the most important thing that you can do so that you can do the rest of the notebook. All right, so you can connect to Snowflake programmatically in different ways. We're going to do the most basic, not recommended for production way today, which is just basically creating a dictionary that has our connection parameters. All right, so you need to fill these out. So there are 3 things you need to fill out: the account, your user, and your password. All right, so the trickiest thing to find is your account. So it's important that you follow along with me as I show you in the UI where to find this. All right, so again, we're filling out the account identifier, which is basically identifying my Snowflake account. So what I'm going to do is I'm going to go back into my account. At the bottom left, you can just click on your initials. It's kind of like an admin menu. And there will be an option that says connect a tool to Snowflake. If you click on that, you get this handy modal that gives you all the things that you would need depending on what tool you're trying to connect to Snowflake. The first one at the top is the one that you need to copy. All right, and again, this is only for option A, folks. So I'm going to copy that. I'm going to go back to my notebook. I'm going to just paste it in. Show it again? Yeah. Cool. All right, so at the bottom left of the Snowflake UI, I'm going to click on my initials here. That'll bring up this small little menu. I'll click on Connect a Tool to Snowflake. You get the modal. Copy the very first value at the top using this icon on the right. So that's your account identifier? Yes. All right, so your username, this is going to be the username that you set up when you activated your trial account. So for me, it's Gilberto. And your password is going to be the password to your account, of course. So I'll just copy it from me. Right, so all I did was run that, and then I created a session. So now my local notebook is connected to my Snowflake account, and I can just stay in here. I will hop over to the Snowflake UI every now and then just so you can see how it materializes in Snowflake, like the things that we're doing, what it actually looks like when I actually build something in Snowflake. But 99% of this rest of the tutorial is going to be spent in this notebook, so just a heads up. But again, if you're doing option B, I can still guide you. This notebook is built to be able to do both. So I can hop over every now and then as well. All right, so how did I establish? How did I establish this connection to Snowflake? I did that with Snowpark, and so that's what the package let me do, is help me build a session here that allows me to connect to this account, and then from here, I can start creating the API objects that we're going to use to build our pipeline. So again, just for quick reference, I'm not going to go through it again, but I just want to show you the architecture. We're going to build all of this in Python, all right, this entire pipeline. All right, this is option B. This is cell for option B. I'm going to skip it. But if you are in option B right now, you should run this. Right? And you can see this is a shortened version of the first cell because you're already in Snowflake. So there's a lot of context already that the library can use to create your connection. So it just gets your active session. I'm not going to run it because I'm obviously outside of it. Won't work for me. First thing you'll need to do is create a root API object. All right, so I mentioned earlier, Snowflake is a package that we're going to use to create a lot of the objects programmatically, tables, databases, schemas, right? And so all I need to do is instantiate the root object. So I'm just going to do this. I'm going to type, everybody should be typing this if you're in option A, root equals root session. Oops, sorry. And this is just saying, hey, create this root object using my session so that moving forward, I can just create everything else. And I can say things like root.database, root.whatever, root.anything. So this is the most, as part of like the actual API flow, this is the most important line of code that you can write. Go ahead and click play.
So that, if you're in B, you don't need to do that.
If you're in B,
You don't need to type anything in.
unless the cell says option A or option B, you should be running.
Okay.
Yeah. So I think the next thing that we're going to do is we're going to create a role that has the specific privileges that you'll need to be able to build out the rest of the pipeline. So why are we doing this? Most folks say, can't you just use the top level, most powerful role in Snowflake or in any database called account admin and just like create whatever and work with whatever? And yes, you could do that. This is a trial count. You're not going to break anything. But I want to show you a best practice here that's known as role-based access control. It's a long, again, there's no shortage of acronyms. So this is frequently known as RBAC. And all this means is that you create a role, give it privileges, and then you grant that role to users. So I can say, hey, role, lab role, you can do X, Y, and Z, and I'm going to grant this to Aisha. I'm going to grant this to Gilberto. I'm going to grant that to users. So all I'm doing here is I'm creating a role called PyData lab role, and I give it the privileges to be able to do certain things for this lab, like create a database or create a virtual warehouse, as an example. And you don't really need to go into the details on this. I've already just set it up for you so that it works. But as we move on through the tutorial, you'll understand exactly why it needs to be able to do database or virtual warehouse. We'll dive into more details on some of these commands. This is already built out for you, so you can just click play and it will create the role for you. And you can see the privileges have been granted. So that line of code that body of code just creates the role and grants the privileges. We need to assume it. We need to use it. So our user needs to actually take on that role. And so all I'm going to do is say session.useRole, and then the name of the role that I just created. All right. So now my session is using PyData lab role. Most of the errors that I see for folks who are working in platforms like Snowflake is, they'll run to access errors or insufficient privilege errors. Most of the time, they're not using the right role. So it's really important to make sure you are set to the correct role, and then just retry operations. All right. So the first thing we're going to do is before we can load data into these tables, we need to define these tables. So we need to create basically these target destinations. There are 3 tables we have to create. I'm going to use Python to create them. The core things that I have to do when I define these tables is, of course, what's the name of the table, what columns are in that table, and then what are the data types for those columns. So what type of data can those columns hold? That's a lot to type out, so I've already pre-written some of this stuff for you, but some of this stuff you do have to type out just so you get a sense of what this pattern feels like. All right, so the first thing that I'll do is I'll define our objects, and again, that'll be those 3 tables. I should mention, just to keep this architecture diagram kind of simple, I didn't show how these are actually nested inside of a database, but all these tables will live inside of a database called Tasty Bytes, inside of a schema, which is kind of a way of grouping tables, called raw. All right, so we're going to do 2 things. We'll create a database, we'll create a schema, and then those 3 tables will live inside the raw schema. All right, so we'll do this programmatically. So I'm back in my notebook. So the first thing I'll do is I'll create my database. I can just click play. There's some stuff we'll have to type out in a bit, but this just creates that Tasty Bytes database. You can see how I'm doing this with Python, right? Pretty familiar patterns. So just defining a name and then instantiating database. That creates an object here. And then I can say root.database.create. Here's that new database. And then I specify a mode. And in SQL, how many folks here are familiar with SQL? Yeah, so the way this would look like in SQL would be, create or replace database, whatever. So this is just how you would do this in Python. And then again, you have to make sure you're actually using the database that you want to use. So I say session.useDatabase, that new database. This is a pattern you'll see frequently as we move on through actually building. the rest of our data objects. So again, you should be following along here if you're in option B. Unless I specify a difference between option A or option B, it's the same sequence here. So the next thing we'll do is we'll create our schemas. So this is kind of how we can group or separate data sets or tables inside of a database. And so we're going to have two. We're going to have raw. That's just our raw zone. Those are the three tables that I mentioned. And then we're going to have another one called analytics. The analytics schema is going to hold all the dynamic tables that I showed earlier in tier 1, 2, and 3. Let's start with the raw tables. So the first thing I'll do is I'll create a schema called raw. So very similar pattern here. And then what you need to type out is creating the analytics schema. All right, so you can use basically this as an example if you don't want to type all this out. Database create. Sorry, actually, 1 second. We have to actually give our schema a name first. So we'll say analytics schema equals schema name equals analytics. So similar pattern as to what you see above. Once you have that, you can run the cell. This will create two schemas inside of that database. Visually, what does this look like inside of Snowflake? So if you're someone who prefers to see how this visually looks and how it's nested and how it's organized, right? You can go to, and you don't have to follow along here. I just want to show you really quickly. You can just kind of go to this visual way of looking at all of the databases in this account. I'll refresh. You'll see I already have Tasty Bytes DB created. And here are the two schemas that I created. I created raw. I created analytics. You can expand those. And you'll notice we don't have any tables yet created. We're just creating the organizational structure of this. I think I saw a question. Yeah? Oh, all right. We have about 30 minutes left. So I'm going to run. I'm probably going to go through it pretty quickly. A good way to scale help is maybe some of the folks are doing the same at your table are doing the same option that you're doing. So maybe just ping them for questions on any steps that you may have missed. So for folks who are doing option B, if you're running into errors, there's stuff that you have to type out with me. And that's because I didn't want you to sit around just click and play. I want you to type stuff out. So that's, again, that's just a few things because I know there's a lot of code. So you will have to write a few things, and I'll show you. For folks who are struggling or don't have that code yet typed out, you can ask folks at your table. I haven't gone very far. I'm just here where I created the schema. A lot of folks are missing this line right now. This is option A and option B.
Are there more lines below that we have to add in manually?
Very few, because I knew because the amount of code, I was like, if it's not going to be sustainable. And I did this at the last minute this morning thinking, it'll be more interactive. But you see, bit of hyperspeed now. This is where I am right now. And we're just building out the data objects right now. So we just have the raw and analytics schema. The next thing I'm going to do is create a compute resource. One thing that I wished was named a little bit different in Snowflake is that virtual warehouses were called compute resources. Basically, this is the computing power that's used to process what you're doing in Snowflake. So it could be your SQL queries, or used also to power notebooks as an example. So all we're going to do here is you can call this whatever you want. I'm going to call this Tasty Bytes Warehouse. So somebody asked me, is there more coding you have to do? Yes, here I'm just filling out a name for my virtual warehouse object. Call it whatever you want. And all I'm going to do now is click play. This is going to create that compute resource that's actually going to power the rest of my pipeline. And I know moving a little bit faster just in the interest of time. This is being recorded. It will be available on YouTube. You have the repo as well. You have the free trial account, so you can still follow along separately if you'd like. Now I'm going to create a stage. A stage is basically a pointer, in this case, to an external location that's going to be holding all those data files. So in this case, I'm pointing to Cloud Object Storage. This is a public S3 bucket. It doesn't require any authentication for me to actually go and grab those files. And once I create that, so first thing I'll do is I'll create it. But once I create that stage, I'll be able to do operations against the files in that stage. I'll be able to actually ingest it. So I'll just go ahead and click play. This creates that stage. Right? You have the name. I created the name, the URL there. You can see what this looks like in the UI. And if you've been creating those tables, right, you'll see that they'll populate down here as well. I'm sorry, not the tables, the stage and the schemas. We'll create the tables in just a bit. You can see my stage is here, and it's pointing to my files. One thing I want to clear up really quickly is I don't have files inside of Snowflake. I don't have files inside of my platform here. I'm pointing to the location that has the files. I'm going to bring in the data in those files into Snowflake and land them as tables. A lot of folks ask me, hey, can I just like upload all my... Yes, you could, but this is a very common pattern where folks are landing data in the form of files in external object storage, and then you bring in that data in those files as tables. All right, so now let's actually define our tables. All right, so inside of the raw schema, I'm going to create those 3 tables. All right, and I'll zoom out just a little bit because there's a lot. All I'm doing here is I'm grabbing a reference to that raw schema. These are all the columns that I want my table to have. I didn't want folks to type that out, so it's already written here for you. Then I create that table here, so I create my order header table object. And then I'm going to say, hey, create this table inside of that schema. So I think this is the last part where I left out something for you to type in. It's important that you actually type this out with the correct name, right? So order header. The reason for that is because subsequent cells will have references to the order header table. All right. So I'll click play. And I'm getting an error. Oh, columns. And I'm getting an error because I haven't specified my columns. And all I can do is go up here to order header columns and paste that in. Now I can click play, and I should not get any errors. So it's been created successfully. This is just the raw table. Doesn't have anything in it. Right? And if I update the UI over here, you can see it's there. All right, so what we've done so far is we're just kind of laying the foundation for how we're going to land data into Snowflake, and after that, we're building the rest of our pipeline using dynamic tables. So from here on forward, I believe most of this, if not all, you can simply click play because these next 2 cells are pretty repetitive. We're just creating more raw tables, right? So this one creates a table called order detail, and just so you have some context on what these tables are containing, order header is basically containing an entry for an order. Hey, order 1 happened at this time. Order detail is an expanded version of an order. So it can have, hey, you ordered a drink and item A and B and C. So it has multiple entries for a certain order. Then I have a fact table, which is a menu table. And this is just a list of things that this company actually sells. All right, so I have 3 tables that I've created. I don't have any data in them. These are just the objects right now, the raw objects that are going to get that data. Now we actually have to bring that data inside of those tables. We're going to use copy into. So if we go back into our architecture here, I'm running this command. This is my tried and true best friend for loading data from cloud object storage. So it's copy. I use it a lot in SQL. I'm showing you how to use it in Python here. But what I do is I create a reference to the CSVs that are inside of the specific folder that's in S3. Okay, and the way I do this, I'm just pointing to that directory via the stage. And then I'm saying, hey, copy into the raw table, order header, into these columns. These transformations are required so that when this argument here is required so that when I pull in, it knows that the first column is, should be order ID, and so forth and so on. And that's because the CSV files that I have up in my cloud object storage don't have a header. All right, so I need to specify what they are. So I'm going to be ingesting about 1 billion rows of data. This may take a little while. I tried this multiple times yesterday. It took about 2 minutes per cell. I would say I've noticed it be a lot faster if I'm in the UI, if I'm inside of Snowflake, and if I'm using SQL. This is slightly slower if I'm outside of Snowflake and I'm using Python. I can't really explain why, but this has been my experience so far. But what I'm doing here, I believe this table has about 243 million rows, and I'm using the compute resource that we defined earlier to actually ingest it. So before I can execute the subsequent cell, I'll have to wait for this one to finish. Once this is done, I'll do the same thing and load the order detail data. Right? This table is much bigger than this one. This one is about 3 times bigger. I think this one has like about 700 million rows. And then we'll do the menu table, which only has 100 rows. So using those 3 these tables in our raw zone, we'll be able to build the rest of our pipeline. All right, so this says I loaded 179 batches. That's 179 files. And if you want to look at what this looks like in Snowflake, you can see here, number of rows, about 250 million.
And when the core.
And then I'm going to run the order detail data, and then I'm going to run to menu. Now, this is probably the part that's going to take the longest for this lab. But again, you saw 250 million rows, took about 2 minutes. This shouldn't take that much longer. It's not really linear. It should take around 2 minutes as well. And then we'll do this last one. So the menu one. This one's only 100 rows, so it's pretty fast. So if you haven't already done these, just go ahead and start clicking play. I'm here. And we're going to need all of the raw data to actually build the rest of our pipeline. And we'll see how fast we can move in the next 10 minutes. So yeah, somebody who just ran this cell inside of Snowflake, so they're doing option B, took about 2 minutes. So as you can see, a bigger table was faster than a smaller table. Still overall, for 1 billion rows roughly, it's pretty fast. About 5 seconds in total. Yeah.
My menu took 1.7 seconds.
Yeah, that one's really fast. It's small.
100 lines, right?
100 lines.
Yeah.
If you've already loaded all 3 sets of data, these are more verification queries. So you don't have to run them, but if you just want to look at what's actually in them, you can click play. And here I'm using Snowpark. This is this is Snowflake's library for doing data frame operations. But all I do here is I create a reference to those tables. And I can just run count on them, and I can print out the count, and you can see in total how many rows were actually loaded. All right, so order detail has loaded 270 files. Menu should be really fast. It's only 100 lines, so 2 seconds. And then just quickly, just to double check, yes, everything is in there. So again, about 1 billion rows. I'm going to skip some of these cells just because they're more like verification queries. But what I want to do is actually build out my pipeline. So what I'm going to do now is basically move through these 3 parts, Tier 1, Tier 2, and Tier 3. And I'm going to create each of those dynamic tables. And actually, I do have to add a lag parameter. So if you remember, in my architecture, I had 12 hours. You can set it to as low as 1 minute. Just write 12 hours. And what this is going to do is it's going to build orders enriched from the raw tables. And the core thing we're doing in orders enriched is just adding some dimensions, some additional dimensions that will be helpful in subsequent tiers of the pipeline. Now, this took me about 16 seconds to create. The first time it creates this, it does have to scan the billion rows across these 3 tables. That's because it's initializing that dynamic table for the first time. Remember that a dynamic table I mentioned, after you define it, will only process incremental changes to the source tables. Right? So 500 new rows to the source tables as an example. When these refresh, this will not process the billion rows. It'll just process the 500 rows in the source tables.
So when you say source, that's the S3 bucket.
So that's a good question, yeah. So this is the source of my data files.
Yeah.
This is my source raw data, I should say. Yeah.
Okay.
Yeah. Thank you, though. That was ambiguous, so I appreciate it. All right, so I gave some options here for building it in Python or SQL. Just run one. And the reason for that is, I used to use pandas a lot, so I thought a lot in pandas and in that syntax. Been using SQL a lot now, so I feel like I like reading it in SQL now. So I gave you the options to just be able to see like what it looks like in SQL compared to what it looks like in Python. I would run one. If you run SQL, I would stick with SQL, especially if you're in option B. And that's because subsequent SQL queries or SQL definitions for the dynamic tables, they reference each other. So it's good to keep one track. Now, if you did both on accident, not a big deal. Just pick one moving forward. You'll be fine. I'm going to build out the rest of my tables, my dynamic tables. Yes.
Quick question. So the F dot in the Python code.
Yeah.
Can you just explain that?
Sure. Yeah. So if you go all the way to the very, very top, the first cell, you'll notice that I import functions from the Snowpark library. So it lets me do things like select a column. So
Okay.
f.column, and then you can say whatever the name of the column is.
Okay.
Yeah.
Thank you.
See if I can build the rest of this in 5 minutes. So these are the tables that take the longest to initialize at first. Again, because they're being built from those three tables, the three raw tables initially. All right, so those are my tier 1 tables. You can query them with Snowpark if you'd like and just kind of see what's in there. Right? I'm just enriching with temporal dimensions. I'm adding to orders enriched. I'm also doing something similar for order items, but I'm adding in things like discount flags and discount calculations. The details of the transformations aren't really important, but they're there if you want to read them. When I go to build my tier 2 dynamic table, I do get an error, and that's because, again, I wanted folks here to type in this lag parameter. And notice I didn't type in a unit of time. I didn't say 12 hours, 5 minutes, 2 seconds, whatever. I did downstream because what I really care about for this table is, hey, I want you to listen to your parent tables, and when those change, you update, all right, and just process the incremental ones. Right now, this you can get as granular as about a minute. Soon you'll be able to get as granular as a second. And this is really good for if you require really fresh data, really refreshing your dynamic tables as frequently as a minute or frequently as 5 seconds, as an example. What I've seen this be used, where I've seen this be used a lot is in streaming use cases, because you're ingesting data really quickly and you want to transform it really fast, and maybe it's being delivered to some system. What I wanted to show in today's lab is how, my claim is that delta-driven or dynamic tables, so tables that process incremental changes and that have automated refreshes, these are really good sources for agents, because if you're building an agent and you're asking a question of that data in natural language, you can be assured it's as fresh, the response that you're getting are as fresh as the lag parameters that you've set for your tables, right? So I don't have to go in and run scripts and just make sure that my agent is up to date. Those tables are automatically being updated, so my agent already will have access to the latest data. So that's tier 2. And then these are the last 2 tables that I'll build. These are the most important tables because they actually contain the metrics that I want to look at. So daily business metrics, and then finally, product performance metrics. So daily business metrics is just like, hey, how many things did we sell today? Product performance metrics is, hey, what are the top 10 products by revenue? And then from here, we've built out, we're here now, all right? And we've built out that pipeline. I could stop here, but like I said, I want to get as far as this because I like it when data engineers can actually see their data product being used. So I'm going to move quickly through this and see if I can do this in 2 minutes. All right, so what I'm going to do is I'm going to build a semantic model that is going to allow an agent to talk to the data that's in there. Semantic model is basically a mapping, a description of my tables. So it's a YAML file. Sometimes they're very long, 600 lines of YAML, 700 lines. I'm not going to write any of it. I'm going to have it auto-generate through Cortex Analyst inside of Snowflake. And then I'm going to say, hey, agent, I want you to use a semantic model. So when I ask you questions, do you know what tables I'm talking about? You know what columns are in those tables? You know what those data types are. So I'm going to skip down here. A couple of things that I have to do to be able to actually create my agent is I have to just quickly create my agent infrastructure. This is just something that is going to hold my actual agent. It's required for any agent that you create in Snowflake. So you have to create a database called Snowflake Intelligence. From here, I'm actually going to move into the UI so you can see what this looks like. So I'm going to go, and I know I'm moving quickly, but I just want to show folks the conversational aspect of this. I'm going to go to the AI/ML part, go to Cortex Analyst. I'm going to create a new semantic view. I want the semantic view to live right next to where my dynamic tables are. So I can just say, just name it whatever. I can give it more context here. I can give it like, hey, you should use these instructions. I'm going to skip this. and I wanted to use all of the dynamic tables in my analytics schema. And then I wanted to use all the columns. Right? I can get really granular and say, hey, I only want columns from this table and this table, but I want to get really granular. I want to have access to all those columns. So this is going to create a semantic view. So I mentioned earlier, what exactly does that look like? It's practically, it's a YAML file that has descriptions of my objects, my data objects. I'm not going to write this from scratch. I'm going to have Cortex Analyst generate it for me. So this is what it looks like, right? And it's really long. Now, just based on what's in here, Cortex is saying, hey, this is a verified query. You're probably going to ask this a lot. Do you want to add this to your model? And you can review it and say, yeah, let me test out the query that you're suggesting. You can check out the results and then save it. I'm just going to move for the interest of time and hit save. So I want my agent, I want to create an agent that is going to be able to use this semantic model. So what I'm going to do now is I'm going to go to agents. I'll click on create. And again, I'm going to put this agent right next to where my data is. My agent. And then PyData. So I'll create my agent. And this agent in Snowflake is able to do two things. It's able to extract insights in natural language from structured data and unstructured data. And then it can also do things like use tools, custom tools, APIs, et cetera, that you configure. We just configured our semantic view inside of Tasty Bytes DB Analytics. So I just wanted to use that. All right, so my view, and it needs a description to understand how to use what we're connecting to it. I'm not going to write it because I don't have time. So I'm just going to click on this button. It's going to use Cortex to generate it for me. This is the last part. I know we're over, so I appreciate you staying for just a little bit longer. This doesn't take that long to generate. It should take just a couple more seconds, but it is pretty detailed. And it's basically describing in a little more detail what that semantic view already had in the YAML file. But you'll see it's kind of in natural language. It's not YAML. It's not code. All right. Add. I have to save it. And then I'm going to click on Snowflake Intelligence. And it's already using my agent. I can say something like, what are the top 10 products by revenue? I wish we could have asked a different question, but we didn't get to build out some other functionality. But what are the top 10 products by revenue? And so this agent, this is like a ChatGPT-like experience inside of Snowflake. And so you can imagine as part of the pipeline that we built, the pipeline here, our data analyst teams are in intelligence, and maybe they're not writing SQL. They want to ask questions in natural language. Or maybe they're not an analyst, and they don't really know how to use SQL. So they just want to come in here and ask questions. But you can see how the agent is thinking and saying, hey, cool, I know how to write the SQL for this. I can give you the answer. But also, I think this is a really good data set to be able to visualize. So I'm going to create a bar chart for you. And you don't have to create a dashboard. So it says, hey, these are the answers to the revenue question you had. Perfect timing for that. And then here's a chart. And you can keep going. You can keep asking more questions and all that. You can also extract insights from unstructured data. So if you have PDFs, you have things that don't fit neatly in tables, you can do that as well. All right, we're 3 minutes over. I want to say thank you so much. Really appreciate everyone coming out to the session today. I'm very active on LinkedIn. I'm constantly posting just in general about data engineering and building apps with Snowflake. So if you'd like to connect, here's my QR code. Thank you again, and I'll see you around. Thanks.